Let's take a look at linear regression in Python. First of all, I'm going to say that there are several ways to do regression. I'm going to show you one particular method because I'm trying to keep things as simple as possible. So I've already imported my libraries. I have my pandas library that lets me import my CSV file and manipulate some of the data. I have matplotlib, which lets me create a scatter plot. NumPy, which you need to format the graphs if you choose to do that. And then the new thing here is the linregress function from scipy.stats. I'm using my coasters dataset again, and I want to do a linear regression comparing top speed and max height of the roller coasters. So I'm going to go ahead and come down here, start a new coding cell. I want to look at the speed and height of the coasters. So to do my line of best fit, I'm going to call this line. I'm going to do lin regress, and then I need my x variable, comma, my y variable. So speed, comma, height. And this will do my linear regression calculations for x variable, comma, y variable. And then I'm going to go ahead and print this output. So you can see that this linear regression gives us a whole bunch of decimals. First, it gives us the slope, the intercept, the R value. Those are the three that we really care about. These other ones, your p-value and your standard deviation calculations, we don't care about as much. Okay, so if I don't really need this, so I'm going to go ahead and comment this out. If I just want slope, y-intercept, and the R value, I can say, well, slope, I want to look at my linear regression output, and I just care about the slope. Okay, so this is going to pull the slope value from the lin regress output. Then I can do intercept, same thing, line dot intercept, and R value, line dot R value. So now I've pulled those three values from this output, and I can use those in some other calculations. So let's go ahead and graph what I have, and then we'll graph our line of best fit. So if I do my scatter plot, I'm graphing speed as my x variable and height as my y variable. I'm just going to go ahead and do plt.show. Okay, here's my scatter plot, looking at the speed and height of my coasters. I'm going to go ahead and label some things. plt.title, coaster speed versus height. My x label is speed in miles per hour, and my y label is the height in feet. So if I want to add my line of best fit to this graph, somewhere between plt.scatter and plt.show, I need to add a plt.plot. I have my x variable, and then I'm going to write my equation for my y variable. So think back to Algebra 1, think y equals mx plus b. I need my slope times the x variable plus the y-intercept. And I'm going to make this red just so it stands out a little bit. So this is going to plot the line of best fit on the scatter plot, and this is in the format y equals mx plus b. So there we go. We have our line of best fit on our scatter plot. Now, if you really need to see the value or the equation of the line written out, you can do that. You can just use some print statements. So I'm going to do print line of best fit equals, let me change this, y equals, oops, slope, then the letter x, oops, plus intercept. So this would be our equation of our line of best fit. Yeah, I could adjust the formatting a little bit and make it prettier, but that's my equation. I can also print the R value. Again, since our R value is pretty close to 1, it means we have a strong correlation and it is in a positive direction. So that is it for line of best fit. One other thing I'm going to show you that we've touched on before is using your equation to make predictions. So I'm going to come down here again and look at making predictions. We talked previously about using an input box. So I can call this speed input. Say that I want this to be an integer. Input, how fast is the roller coaster? Then I'm going to print the predicted height of the roller coaster traveling at whatever my speed input is, miles per hour is, and then I'm going to do my math. I'm going to go ahead and go down here so it doesn't go off the screen. I want to round this value, slope times speed input plus intercept. I'm going to round it to 3 decimal places, and then that is in feet. So how fast is the roller coaster? Let's say we have a roller coaster that's going 40 miles an hour. The predicted height of that roller coaster would be 52.349 feet. And then you can do the algebra to do the same type of thing, but input height and output speed. That is it for linear regression.